Okay, so now we'll look into the categorization or classification of vectors. So I'll just say categorization. So the first thing that we'll study is equal vectors. What are equal vectors? Vectors which are exactly have the same magnitude and same direction. It is not important whether they share the same origin or not. Okay. So for example, if I have a Cartesian system, if I have a force vector, let's say F1, okay, another vector F2. Okay, so F1 and F2 are equal vectors. Okay, however, you can look into it that they both are not acting at the same place. You can simply write it as F1 is equal to F2. That's it. Second thing is collinear. When we say collinear, that means it has to be parallel vectors, exactly like same. The only thing is I can have an F1 vector like this and an F2 vector exactly in opposite direction. Also, the magnitude could be different. It could be that F is exactly right after this F2. So they are collinear. Okay. Third one is co-planar. If I say co-planar vectors, let me again take my notebook. So if I have two vectors, let me use my markers here. So this is a plane. I have a vector here in this direction and some random vector at very odd angle. Okay, you can look into it. So these two vectors are lying on this same plane. Okay, maybe of same magnitude, maybe not, maybe of same direction, maybe not, but as long as they're lying on the same plane, they are coplanar. And where do we see coplanar? If you are solving a problem only in two dimension, let's say x and y. So these, for example, this one is also a coplanar. These two are coplanar vectors. Okay. Fourth is free vectors. Free vectors are something which actually can be drawn at any position. Okay, they are not bound by particular origin point. Okay, I can drag it to some other location. I can move the origin to another location. So most of the kinematics variables that we will be using, for example, velocity, acceleration, momentum, all these are free vectors. You can move the origin in here and there. The only thing is don't change the direction and don't change the magnitude. That is one thing that you need to remember. So those are free vectors. They are free to move but cannot are not free to change the direction and magnitude. Okay, next is localized vectors. Now this is very different from, very opposite to what free vector is. Free vector says you can move around, you are not bounded by any origin, whereas localized vectors are the ones which are bounded by the origin. You cannot change the origin. It okay. So wherever it is actually starting, it has to be exactly at that position. Some of the example that I gave earlier, right? I told you an example of position vectors. That was RA and RB. Okay, so the position vector is bounded by the origin. So these are localized vectors. Clear? Okay. Last one, orthogonal vectors. What is orthogonal vector? Orthogonal vectors are the vectors which are actually perpendicular to each other. It could be in any plane. Okay, you can always change the plane. So for example, if I show you like this, these two vectors are orthogonal. Direction can be different. Direction doesn't matter. It has to be 90 degree. I can change the plane. So these are orthogonal. Great example of orthogonal vectors are the Cartesian coordinate x, y, and z. Okay, they are, all of them are orthogonal to each other. They all make 90-degree with each other. So they are the classic example of orthogonal vectors. What? All the unit vectors I, j, k are orthogonal vectors. Clear? Okay, great. Now we will actually talk about the fundamental mathematical operations of vector. How do we handle mathematical operations? Okay.